Okay, this question is kind of a preview of a situation where we talk about whether or not the reaction is written, is spontaneous, when that means the forward reaction, or maybe it's not spontaneous, in which case the reverse reaction might be spontaneous. And ultimately, this is getting around to a concept called equilibrium, but we're not there yet in this particular sequence of learning for this particular course. So what we really want to hang our hats on is whether or not the reaction is spontaneous or non-spontaneous and how that relates to Gibbs free energy. Well, we know from the free energy equation that when a reaction is non-spontaneous, that means that delta G is positive. And when the reaction is spontaneous, delta G is negative. So, well, what does that mean then? What is the transition between spontaneous and non-spontaneous? Well, that transition going from negative to positive or positive to negative is when delta G equals 0. Now, we're going to learn more about that later. That's when the reaction is technically at an equilibrium, but we haven't got there yet. And so we need to move on just past that and just think that what we need to do at this point is we need to take our free energy equation and we need to say, okay, when delta G is 0, then I can figure out this temperature at where this transition happens. And so the rest is just solving it algebraically. So adding T delta S to both sides and then dividing both sides by delta S, I get the equation to figure out what temperature this happens at. The only thing is that if you take a look back up here in the reaction, my units for energy and delta S and delta H are not the same. I just need to make sure that they are before I tackle the problem. So I'm going to convert kilojoules to joules, so 92,200 joules per mole. And I'm going to then divide that by 198.8 joules per mole times Kelvin. Joules cancel with joules, moles cancel with moles. I'm left with Kelvin, 1 over Kelvin in the denominator, which means that Kelvin moves up to the numerator. And so I get T equals 463.8. Doing the sig figs, I get 464 Kelvin. Now, is it that temperature and above or that temperature and below? Well, remember that delta G was equal to delta H, which was a positive number, minus T, which is always positive, delta S, which is also positive. So that means that this quantity in red is always positive. And so I'm subtracting a larger number. And so if I want delta G to be negative, then that quantity in red has to be big. And so it's 464 Kelvin and above. That's the temperature. And that's it for this problem.